All right, guys, welcome back to another KevCAM night class tonight. Got something special for you guys lined up, but first things first, I want to kind of cover with you guys because I just do see a couple new names in here. We do use GoToWebinar for all these night classes for you guys, and what this does is it puts everybody on mute just to eliminate any background noise. But if you guys do have a question, and we definitely encourage you guys to do that, there is a questions panel for you guys, and you guys can type that in there, and we will answer it all on the fly for you guys. So think of it as a kind of a laid back, no structure to it. If you guys got a question, please feel free to ask it, and we'll go from there. So that being said, what we're going to do tonight is we have kind of a special guest, Ronnie Kidder, on the phone with or on the meeting with us here, and he is going to show us the Eureka software and how it integrates with SolidCAM, and going back and forth. And Ronnie's using this stuff on a day-to-day basis and kind of showing you guys the ins and outs on how it works and taking it from the customer side of things. So, Ronnie, are you with us?
Yes.
Perfect. And then, of course, we have Greg Payton along with us as well, and we have a whole crew of guys tonight. So we have Greg Payton helping out, Tim Micah helping out, and Ken Merritt also helping out. So got the whole crew of guys, and just because we're all kind of interested in seeing the Eureka software. So before we get rolling here, I just want to throw one little clip up here that if you guys do have ideas, send those over to me in an email, and we'll get those added in there. And Richard, do you have my email address? I'll just put it in here just in case. So Richard, if you ever do have an idea, send it over to me email. And those of you guys that are watching this on YouTube, my email address will be down below. And Ronnie Kidder has also put his email address in there for you guys as well. So any questions kind of geared more towards the Eureka side, he'll be able to help you out. Now, Ronnie does not work for Eureka. Ronnie works for himself, but he just uses the Eureka software, likes what he sees in SolidCAM, and just kind of want to show you guys a customer view of doing the night class tonight. So, all right. With that being said, Ronnie, let's get a little background information from you. How long have you been using SolidCAM, Ronnie?
3 years.
3 years? Okay. Now, when you were going through the process of finding a G-code simulation program out there, did you just kind of come on Eureka and find Eureka only, or did you try out multiple different softwares?
Yeah, I tried out IMS Verify. Well, no, I inspected IMS Verify. I had temporary licenses for NC Simul and Vericut, and I came across Eureka actually through a SolidCAM demo, and I saw it on the tab. So I got some information about it and contacted them. And saw a demo in it, and it ended up that we were able to give it a shot and liked it.
Cool, very cool. So let's, what I'm going to do is I'll switch it over to Ronnie right now, and Ronnie will kind of show us on one of his parts for you guys on how it works. And like I said, if you guys do have questions, definitely throw those out there, and we will get those answered right away for you guys. So, Ronnie, I'll switch it over to you right now.
Okay.
And everybody should be seeing Ronnie's screen. Yep.
Okay.
Okay, we're good to go there, Ronnie.
All right, let me close up this here. Okay.
And right. just a little admin thing. Guys, if you see that control panel for the go-to meeting, there's a little orange arrow that you can use to minimize that to get that out of the way and see Ronnie's screen full screen. So the floor is all yours, Ronnie.
Okay. Well, hello and good evening to everyone. Many thanks to SolidCAM, Kevin, Tim, Greg, and Ken for making this possible. And as Kevin said, I came to SolidCAM 3 years ago after looking at several other packages. And I want to say at SolidCAM, they really take care of the customer with some really good people. and it's a first-class software. And thanks to all for attending. Really appreciate you taking out the time. So I'm going to keep this short. So Eureka is a simulation software for CNCs and robots, and they've been at it since 2001. Personally, I call it stress reduction for programmers and setup. And that's because Eureka is going to run your posted code on your particular machine. You can find all the collisions and verify your program dimensions by comparing the cut part to the model and highlighting the differences. So once you're satisfied with your program, you can send it out with a detailed setup sheet with all the information and go back to working in peace, knowing you did your part. Setup will get it. They build out per your setup sheet, load the program, review it at the machine, and cycle start with just checking your offsets and run the part. So you got less time on setup and more output.
Now, the cool thing with, and this does get a little confusing for some people, is the SolidCAM simulation is just basically reading the operations, where Eureka is looking at the actual posted code itself. So it has nothing to do with the software. It's fully looking at the posted code that has come out of SolidCAM.
Yeah, it's basically a reverse post processor, and so the virtual machine inside is gonna just like if it running it at the control, because it's got a control particular for the machine, and just like your control, and it'll emulate the moves. So they'll support all different kinds of machines. Excuse me a second here. All right, and let's see what it did. Okay. And in all different kinds of controls. So, and if you don't have one, they'll set you up with one. So, after you machine your part, you can take dimensions. You can also compare your cut part to your original model, and you see the different size variations. You can make hand edits, and then you can re-simulate your hand edits. And if you've got programming routines, you can simulate those also. You can use it to calculate the minimum tool length, so you can minimize your overhang. And at the end of it, if you need to, you could export your machine stock. But we can also do that in SolidCAM. So if you don't have if you've got another system over there, but you still want to use this, you can have CAM interfaces for other software, and then this is nice where you could use it for training new programmers, where instead of practicing on a trying to go run the code out of the machine, well, you run it here and you can grade them and see how they're doing, and then get them to be some good programmers for you. They can handle CAN cycles and part transfers, bar feeders, spindle handoffs, main subs, and sliding headstock machines. Also known as Swiss machines. We also have this tool, Eureka Cloud, where you can actually send out. Eureka can run in the background, and it'll let you know if it's good or not, and it can send it out to the machine. And this is what we were talking about earlier. You got a couple of ways you can view at the machine. You could have a PC-based version, Eureka Viewer, or an app that will run on your phone or any place you can run an app, tablet or whatever.
See, I think that's the real cool part about it is because, everybody has their phone with them all times, and, you may not have your laptop or computer sitting right next to the machine with you at all times, so you can pull it up on your phone and look and make sure everything's good and not going to crash on you before you run that part in that machine.
Yeah, check out, see, and then you can move around and see the whole thing, in which I'll show you a little bit more about the viewer in a little bit. Also, you can program your robot with using SolidCAM 5-axis, and you can simulate it in Eureka. So, Well, enough jabbering. Let's see about, making our part here. So I got one up, and in here I'm using this chuck as my fixturing. It's inside the machine. Just depends on what size of part we're running on it. Depends on what we have, a 2-foot chuck or an 8-inch chuck or a 12-inch chuck, depending on what we're doing. So what I like to do is, as Ken's talked about, we should get a green light in our SolidCAM, and everything should be good in there. And if it's all good, then we would want to send it out to Eureka to do our final verification. So make this like 2 green lights and then send it out to the machine. So let's take a look and kind of run through this one, simulate this one, and see where we are, what we're doing. So we're facing and turning. Now we can do a finish face, finish turn, face mill. Drill, and then we got to use eye machining at some point. I just wanted to, it's a little, I was concerned about bandwidth, so countersink, and we'll rough our pocket. Finish our pocket.
Now, Ronnie, I'm sure we're getting there, but
Yeah,
did you have to do anything special to the SolidCAM program to prep it for use of Eureka?
Yes, we sure do. So let's go back and take a look at that. Well, before we run off, let's check it out. So we got our setup here. This tidbit here from Kevin here. This makes a difference. Helps you out. Put a 1 there, and you can see we got a good sizing. Okay, so that's all good. So inside, we have a couple places that we want to set up. First off, we want to, the machine we're going to send it to, we want to tell it where we're actually going to. So in our setup, we position here at 14 inches, and that's referenced from the machine 0. And that's would be not the same as your Mach 1. So the program follows Mach 1, but Eureka's got to look at the zeros looking at the machine. Also, we'd shown our stock, our fixture, and here we selected the solids for this. So you're going to deal in solids, in which this is no extra deal here to do that. That's one part of it. And the next part of it, I'm going to come over our part settings, come over to G-code simulation. In this case, we're going to pick out the machine we're sending it to, and it's a E650 Mazak. And if you have stock you want to send, of course you're going to want to click that off in the target and your fixtures. And you can specify what directory that you actually want to put the files for that you're going to create in all of this business.
Okay.
So we have, click OK on that. That's really all you got to set up.
So in all, the base, I mean, just for Eureka, the only thing you really need to set up is just a G-code simulator, because when you guys do we've talked in a lot of the night classes of adding the setup and putting that fixture in there. You guys are all used to doing that portion of it. The only thing I guess additional would be putting that Z dimension in there on how far that part is from the spindle. So pretty easy, simple so far.
Yeah. And if you have a lathe already set up, you may have the you probably would already have your chuck in there, and you may just be sending your jaws with your part. So you would just attach that. So once we have all this information, we need to get it into Eureka. So you have an interface. So we come along, G-code simulators. So you have all your different choices. Well, the first time you want to send all your data and run your simulations. Click on that. So it automatically opens it up, transfers all the information, populates it. The first thing I'd like to do is see our program window, which pops up on my second screen. So you have kind of general layout, and so if you're running and you're working to send this out, I'm just going to proceed as though I would be sending this job, getting this job run through, so I want you to see that it's pretty straightforward. So I'm going to just cruise through the part, and you'll kind of give me some feedback if this is too fast. So right now we're running optional stop. You can see the tool trace. It's coming out there. Speed up on that a little bit.
I think the speed looks good, Ronnie.
Okay,
yeah,
good.
absolutely.
Thanks. All right. So now we're going to go to finish face.
I like how it shows that, you know, like right now, you see it in a still movement, but right now you can see that spindle rotating because you don't see the jaws.
Thank you. And the tool paths are in your way. You can turn those on or off. You can also set the lengths of the tool traces. We go back through, we get a drill. And I have it set up on optional stop, but I can turn off the optional stop and let it run. It's probably a little fast. Getting kind of busy, so I'll turn off the tool traces. And that's what I want to see. No errors, no warnings. So now I've gone through without bumping anything. So let's see if and here's we can set our levels. We can customize all this information here. Click OK.
So what Ronnie is showing you guys right now is basically the same thing that's inside our Solid Verify inside SolidCAM, which is the stock target comparison, which is going to let him know how much material is still left or if we gouged into the part and whatnot for you guys.
Okay, so we'll click OK. It's going to come in and take a picture. It keeps your range up over here. And one of the nice features here is you come in here and take measurements right off of it. So, in full disclosure, normally I'm going to read this to be within about 0.5. And you can see it's pretty low here. It's a very small number.
Yep.
There's a corrector that's going to get fixed. So, what's another feature here? Something else. So if you're measuring and you start looking at how much material you're actually leaving, you see the different values as it picks them off. Okay.
Now, Ronnie, on the Eureka side of things, is there like a facet tolerance
Yes.
set up? So, okay.
Yes. And I've intentionally kind of left it a little rough for speed, or just in this case, in case I'm using too much, taking up too much of the time on the bandwidth or anything like that. So I want to make sure that it runs this through. But you can get a nice good finish, and you can see it all there.
And we got one question that came up, Ronnie.
Sure.
Is there an option so after the tool path, one tool path is done, it will clear out the trace lines?
Yes. You can set the length of the trace lines. And once you can adjust the length of them. Okay. Yeah. So, and it's going to vary. not exactly sure if it'll work off of each tool, but I know that you can set the amount of them. So eventually the preceding tool will fade away.
Sure.
Okay. All right. So now that we have gone through this part of it, we might want to create a. Now we can create the simulation sent out to the machine. So I'm going to stop this, and I'll get that kicked off. Turn it on. I'm going to rewind. So now there's another option. So instead of having to sit there and you already watched it once, you know everything is good, you can let it run in the background and update periodically. Get to the end for us pretty quick. And you can see down here on the bottom of the screen where I'm kind of circling, that's each line of code that's running. So we're pretty much done. Now we can save this. And what I like about this right here is you can save to either the PC based, or so you could save one and then you'll come down and go through the process again. So we'll save this one. Okay. So now go through the save again and pick the one for our app. And we would save it at the same time. So you don't have to go through all that extra effort. Okay.
Now, are there any differences between the PC-based viewer and the mobile viewer?
Yes, there are less options available to see, to work the part. And I haven't tested out the mobile app to my own satisfaction. I use the PC-based, so I haven't been able to speak about that one yet.
Okay.
Okay. But you're not going to have as much functionality. It's just, it's going to take up too much horsepower. Okay.
But if you wanted a lightweight option, could you load the mobile recording on a PC?
I don't know the answer to that question. I'll have to find out. I don't know.
See, not Ronnie, you're in the hot seat for once, and not me.
That's fine. I don't know the answer. All I'm saying is I'm gonna find out. I don't know the answer. And to me, there's no shame in not knowing. There's only shame in not finding out.
Yep.
I don't know that you could run. So you're saying run the PC based, run the mobile based on the PC, right?
Right. Yeah, just in case you wanted to save out one file, if you could look at it on both the PC and on the mobile.
No, they have two. Well, I see that they have two different extensions.
Right.
So I would. My gut tells me no.
Okay.
Okay. Got out of that one. Okay. So, all right. So, so now once we have this, we can send it out to the machine. So that's fine and great, but I kind of like to see it crash myself. Let's go take a look at this. So we got some operations to have here that didn't quite show. So we're going to unsuppress these.
And Ronnie, are you having to run any powerhouse computer to run Eureka, or are you just able to run standard?
No, it takes a lot less horsepower than SolidCAM.
Okay. No, that's good to know. Just because I know, like with the Eureka, those are you definitely need a computer, especially if you're doing any size of parts to kind of back that.
I say that I've checked the system requirements, but 8 meg, you have to have at least 8 meg. That's a long time ago. 8 gig of RAM, and at the same you have to do.
You're talking about IBM AT days or what here?
So I have a couple other processes. Let's check these out. See what's going on with these. So we're going to sit here and we're going to cut again and into the part. So when we get through this part, in SolidCAM, we're going to see that, okay, right, we've cut the part. And as well we should. But, okay, so that's one issue. Let's see if Eureka's going to pick that one up. And so our next one, okay, so we're running the tool holder into the part. So I said it'd check all collisions. So let's send this back over to Eureka. So we'll close this one. This one over here. We'll send everything back.
And once you guys purchase the Eureka side of things, where you see right now where it says G-code simulator, that will actually populate on your guys's as well. So that's just a on-off switch that we have to do in the license for you guys. And if you guys are looking at your software right now and saying, hey, I don't have that machine simulator, that's just because it's not turned on.
Okay, so the search, I happen to know it's Operation 15. There's a search up here. So cutting too deep. All right, so I'm going to close this out. And so you can restart where you need to. You can update your stock, which in this case we want to do. We'll do that. Clear out our messages. So we're ready to zoom in here. Come in, we'll let it play. So as soon as it makes contact and violates the boundary of the part, it says, hey, wait a minute. And it's not a rapid move, it's a feed move. And it says, hey, and we're only feeding it 4. So it says, hey, we don't want to do that. So we'll just let it play through. So if we look at that, come in here, take a measurement. Yep, that's about right, another 100 thousandths deep. So we can obviously see on our scale that it's working for us. All right.
That's the oops moment.
Oops. Yep. And so let's see if it picks up the bumping of the holder, which I'm counting on it.
Spoiler alert, Ronnie.
That better work. I'll be upset. Okay, so it did. It picked it up nicely. Okay. So and same here. So if you were, if any part of the machine bumps itself, if I'm working really close to the chuck, and the benefit of this is that it'll, notify me of a collision, run into the wall, or if you have a 3-turret machine or a 2-turret machine, and you've got some tools hanging out, and you run along and you poke the wall, or you poke the other turret, or you run into the tailstock, run into the chuck. Well, all of those pieces, you're going to pick those up. Okay.
Now, I think the really cool part of this is, you guys are seeing his tooling already set up in here. Ronnie didn't have to do anything, in Eureka to do that. That data was all carried over, from SolidCAM into Eureka. So, the thing I like about this is it's so well integrated in, just like, how we are integrated with SolidWorks. Eureka is integrated in with SolidCAM, and it grabs all the data that it needs and brings it over with it. So,
as it brought in the holder and the tool, all the stick out, everything that was there, the information with it, each one. So pick that one. And if you want, you can always add tooling if you want, but why do it twice? I mean, there's no savings. I'm all about the interface. That makes it usable from my standpoint, being in a small shop mindset. I don't have time to work on this. So I want to be able to get the project, verify the project, and be able to get it out to the machine. And what I showed you the steps are, those are the exact steps I follow.
So Ronnie, it's time to ask you a question.
Yeah.
Which one do you trust better? The internal simulation or the G-code simulation?
Well, I'll be all honest. You know, if I'm going to do this, I have to do both, because I'll be honest, it's like any piece of software. You know, you gotta before you, just like you're going to go out and prove out a post. Since this is a reverse post processor, you want to go out and prove these things too. But the fact of the matter is that, you know, when you get two green lights, one from SolidCAM and you get one from Eureka, like I say, I'd go out to the machine, check my offsets, and I press cycle start. I don't have any compunction doing that after I've been, you know, after working with it. I really don't.
Okay, awesome. Thank you.
Yeah.
Now,
so,
Ken, maybe you can speak on this a little bit too. Is in machine simulation inside SolidCAM, it is not reading the G code, but is more or less reading the operations in some pieces of the G code.
Actually, in the machine simulation inside SolidCAM, what we are doing is actually looking at the actual toolpath motion that is being generated by SolidCAM. Now, what some people do, for instance, years ago, we did not have machine control operations, and so things like return reference to home between tool changes was something that got added into it at the post-processor time. And so the internal simulation did not see anything of that because it wasn't something that the tool path was generating. It was something that was generated as a function of the post-processor. Now with the true machine control operations, we have a better opportunity to create that motion in the CAM tree and give a better sense of what is happening. We still have to go through a post-processor to generate the G code. And so therefore there is always that potential that if a G code, post-processor has not been proven out correctly, then the movement that takes place at the machine may not represent exactly the movement that took place inside the internal machine simulation. And so as Ronnie was saying, the opportunity to have a G-code simulator from a different manufacturer actually look at the G-code and read that back into motion gives you that opportunity where you don't have the fox watching the hen house. Because now it's not SolidCAM that's telling you that that G-code is correct. It's a different company, namely, the Eureka. And so you really have a double check, if you will, and that extra sense of security.
So it's kind of like the old saying, carpenters, they cut twice, measure once, and machinists measure twice and cut once. So we're just double checking.
I always used to say I cut it off 3 times and it's still too short, so I don't understand it.
It's so true. Yeah, and that's another piece of it. So when I'm checking, and I have to send a job out, so that the part I'm talking about where I can go back and work in peace, I don't have to worry about somebody calling me at 2 o'clock in the morning. Because I'm comfortable, and if somebody calls me and they tell me that I got a problem, I'm going to say, I bet you do. Because I'm listening to what you're saying, but I'm confident that I have done my job, and I'm comfortable that I sent out a very good program.
Yeah, because at that point you've checked it once, you've checked it twice on 2 different complete softwares. So as long as the tool length and the work offset are set correct, should have no issues at all.
Yeah. Absolutely. Well, I'd like to, if y'all got time, I'll show you a little bit of a tour, kind of take you around inside now.
Definitely.
Okay. So normally if you're using 2 monitors, well, of course you could make this as large as you want, dump it on the other monitor, and especially if you have like a 3-turret lathe, you would have 3 windows, 3 channels. So you would, separate those out so you can see your screen. But you can also put in, and you can come up and set you up some breakpoints. And in this case, I have one where you can, open this up, for the optional stop. So every time I see optional stop, I'm going to stop. You can override them individually, or you can override them on a global. So that's another piece there, and you can add them in wherever you want. Put them in, take them out. You can also make them conditional if you want to do all that. But from the standpoint of just using the software, you really shouldn't need any of these things. You should be able to send the program over to Eureka and run it. You may want to set you up some different views moving around inside here. So you can click on any of these views. Take you around. Roll it around.
Can you use your
get all
3D connection mouse with Eureka?
Yep. You can use your 3D connection mouse. There we go. I personally like it for when, as soon as I get fine movements, I switch to the roll of my mouse. I find I get better control.
Okay.
Because you have this large machine in this case, and of course you could turn off, and I have some views set up that are created, different views, and I can cycle through these views. So I'll show you that. So one's a standard machine view. Here's a fixtures in the target. This is adding in the tool. And now I can have the machine view, back to my machine view. Okay, so you can actually come up and create your own views by turning on the features that you want. You turn these on, and then you come along and you can save the view as you want. You can name the view, test, and you can save it. Like that, you have a view.
Now, did you have to provide Eureka with any models or anything like that for this machine?
They actually, well, it's the same policy. They would like to have a machine, and if not, if you can't get one, then you can always build you one. We can go through the, take some measurements, and you don't have to have. All you really need is the inside, of course, right?
Sure.
No, all the rest of it doesn't matter. So, and then get you fixed up. And if you don't have time, like you could buy it as to where if you want to create your own machines, things like that. I mean, we're in the business to make parts and make money, and so I'm of the attitude that pay them to do that for us. Just like you'd want to build, just like you'd let SolidCAM do you machine simulations.
Yep.
Okay. So they have all different kinds of, different types of viewing. That's pretty much the kind of like the high point of that. You come in, you can look at the tools if you want to make any changes. However, using the interface, any change you make, as soon as you hit the rewind button, it'll erase most of the changes. So there are ways to disconnect it. I'm a top-down kind of guy. So I always go back to, if I didn't have the right information, I'm going to come back to SolidCAM. I'm going to make whatever change I want to make in my tooling or in my program. I'm not going to make any hand eds inside of Eureka because I want to have that continuity going forward, because if I send this back over, well, I'm going to overwrite whatever I did. So I want to keep all that together. All right. You can, if you notice, this is the kinematic tree, which for the most part better look like what's in SolidCAM. If it doesn't, we got a problem. It's got to line up. It's got to work the same. So it's your machine, your individual machine, and whatever options you have on it. you can isolate the stock or the part, either one. If you want to, you can determine, what you can affect all your collisions. You can turn things on and off as you see fit. You can have control over it if you buy the machine working option. But personally, I keep it simple, and I would not, work on any of those things. I just want to use it. So come along. You can, inside this message window, you got a problem. You click on it, take you where you have a problem. Double click on it, and you can see where you're going, where your problem is, and why. All right. So let's see. Let me see anything else right off the top. And we go into a lot more detail. I do have one more thing where, if you want, this is something that they have an optimization where you can increase your metal removal rate, and that's one of the reasons why I chose the pocket move. Or if you have let's say a high feed mill where you're taking, so you cut a lot of air with those, and you have uneven cuts, facing or what have you while you're doing that. So I have another program I can show you, another setup.
Perfect.
See that one?
Absolutely.
Okay. Let me get that. Let's see here. That one open. Okay. So it's just and you can make your file standalone, and this one is. Let's just run through this one, kind of get a load of what it's doing. And what I want to show you is that this is probably kind of fast. You can see you're just running through a bunch of code. So, okay, so we'll see the time down here. So far, it's a minute 22. So your time here is going to include, all your rapid around and everything else. All right, so let's stop this. So this optimization, right now, running 4,300 RPM about, and this is some kind of a crazy code. It took me a little bit to look at it, but this is in millimeters per minute. It's 2,500, so it's running about 64 inches a minute. And so I looked at that and said, okay, what's some reasonable numbers to change this? So came along, and you can turn on optimization. It looks at the diameter, all of this information about the tool. You can come on, and so this is 40,000 millimeters per minute. It sounds like a really high number, but it's actually about 1,000 inches a minute. So I said, well, okay, let's assume that the feed rate that they had, the 2,500, was about 80% of the cutting data. Because when we go look in the book, they give you a range on the tools of what you can feed it. So I said, well, let's be conservative. And so it runs through a fairly, they publish all the formulas, and they're straight machining formulas. And they give you a range. So I said, okay, well, let's see if we were, not 100% optimization. Let's just, 95%. Well, what would that get us? So let's come in here, and I'm going to stop this. And I'm going to turn on the optimization. I'm going to rewind it. It's asking me if I want to restart the stock. Yes. Let's run it. So what's going to happen now is just to optimize time. So I said, okay, you can go as much as 20% faster. So it's looking at everything. So it's speeding up the time that you would be in air and actual cutting also. So you can see it's like 2.5 minutes versus 2 minutes. So I run this thing out and get to a point where it's like 10, almost a cycle time of almost 11 minutes versus 14.5 minutes. So it really knocks some time off of it. And that's not, that's not even being, overly aggressive as far as, just mildly, saying 20% increase of your cutting data. So it's maintaining the chip load and everything else. It's not just 20% increasing. It's looking at, the width of cut all along the way and the depth of cut. There's a whole lot of stuff you can control on it. Okay.
Oh, looks very nice.
So
I think now would be a good time to see if we've got any questions from our audience here.
Sounds great.
Yeah, anybody got any questions? Not seeing anything coming through.
That means we had a thorough presentation.
Or everybody left.
No, they're still out here. I guess from the audience view, what do you guys think of the Eureka interface? Well explained and I liked it. Thank you, Ben.
Thank you, Ben.
Now, Ronnie, what was it that drew you to Eureka in the first place, or possibly a G-code simulator? I know we talked about having that secondary verification, but what is it that led you to Eureka?
Stress reduction. Seriously. I mean, stress reduction. I can't tell you, you can stress over this. Unfortunately, I deal in parts that are expensive. The stock might be $60,000 sometimes. That's very rare, but it's been the case. And so when you go do a job like that, you're really sweating those kinds of things. But just the peace of mind of being able to, or it may be a $500 piece of stock, or it might be production. But anytime somebody goes out to the machine and you struggle with it, and you say, man, I couldn't see that. How come I couldn't see that? Well, you're not going to see it. You're just going to see the part in most cases. And if you have machine sim, you're going to see the machine. But what I like is that feeling that I've closed the loop. I'm going through the code, and when it goes out there, I'm really not sweating it. I have a lot of comfort in that, and that's the. Because the downtime is what kills you at the machine. Setup is everything. Getting that down, and stress reduction for the people that are at the equipment.
Now, early on, you said that you were testing multiple versions of G-code simulators. What was it that eventually led you to Eureka?
For the price, I got the quality that I felt was representative of it, and if I've got any problems, I get good help. And so those are the main things. It's always price, quality, and delivery.
Where is Eureka out of in the States?
Well, there's the rep is out of Arizona, and also in Georgia. It's rep in Georgia. That's Alan Weeks. They have Opti Solutions. And so the base is out of Italy.
Okay.
So Robor's out of Italy. And they're pretty much, you haven't heard about them, but they're coming to the U.S. I mean, they're big in Europe. Lots. In fact, they just sold 23 seats of Eureka, and they beat out NC Simul and Vericut. So, I want to say it was South American account. So that was so they went up. Somebody looked at it and said, "Okay, well, we like you," and they're going to do the Eureka cloud and everything.
Yeah, and if you think about it, you mean, one tooling crash, like you said, especially if you got, $40,000, $50,000 just wrapped up in the stock alone, more or less downtime on the machine.
Yeah, that and the expense of your equipment and the downtime of, if it's a 2-axis lathe and I'm running work that's, commensurate with that machine, so my parts, it just as soon be a very expensive piece of material, because if I bump my machine or everything else, or I bump my tooling, then of course I'm down, and I need that job to pay for, everything else, everybody's, salary and, tooling and electricity and everything else. So it's all relative. And, if we're lining up the turret, we're not making any money. And if we're buying, we might be sending, the cutting tool guy a bunch of business, and I'm sure he likes us, but, we're not. It's not putting any food in our plate. So.
Yeah, not to mention a crash spindle could cost you up to $30,000. So.
Yeah, there you go. I mean, a classic example is I had a customer that had, he went on his horizontal milling machine. Somebody crashed the spindle, and they came in. It took a little while for the guy to come in, so they replaced the spindle. It was $7,000. 2 weeks later, they were calling the guy to come back in and put in another spindle. Same machine.
Yeah.
So that gets to be quite expensive, and everybody knows this. You cannot press feed hole fast enough.
You get the old butthole pucker moment going.
Yeah, you can't do it. I don't care. I mean, I don't care. So it's just, I use that as an extreme example, but, your machine might be expensive, or your part might be expensive, or you need to get your job out. And how often do we find ourselves in a position where if we could just get the throughput, because that's where we make money. You want to make money the first time you run the job. You don't want to count on repeat work. You want to get out there. You want the part to go through the machine, and you don't need any hiccups.
Yeah.
Hey, just a note here. I see a comment in here from Ben about on a really expensive piece, you might still use a block of wood or plastic to run it out, prove it out first. And yeah, Ben, that's a lot of us do that. One of the things that I found, and I kind of ran into this by accident. I messed up on a project many years ago, and we were running it in Wren shape to do that prove out. Well, I had a rapid move that went across the part, and nobody was standing at the machine for that particular move. And you know what? It cut the Wren shape just fine. But when we came to the steel, it didn't like that steel so much. So if you're not there to watch every move of that prove out in the plastic or wood, you can still wind up with a problem. Whereas with something like Eureka, you're going to see, the collisions report that's going to show you that move, that rapid move especially, was through the material. So yes, we can do an awful lot with proving things out in wood and plastic, but there's nothing that matches the security of seeing it in internal simulation and showing no crashes, and seeing it in G-code simulation and showing no crashes. Much higher level of confidence. Go out there and push that material, especially if you're looking at the titanium or something like that, where you could be, significant amount of stock.
Yeah, there's no, I've been at this since about '98, writing programs, and I only wish that I had this tool And then what I didn't have, even when I could afford it, I didn't have the time to implement it. So we'll help you get it implemented. I mean, that's not which is, I think, is just a savings in time and effort. So it's not like you're buying another piece of software where you have to completely, I know like SolidCAM, they help me out, post everything. Ken's been great. Florin, tech support's been great. I'm surprised they haven't run me off yet, but it's still early. I've only been over there 3 years.
Never.
Nah, we love you, brother.
Thank you so much.
Ronnie, we couldn't run you off, then I'd have nobody to pick on anymore.
And not to mention the way you're going through punch cards, I think your next support call's free.
Thank God.
No,
I just thank y'all so much, and thanks to everybody else for taking the time and listening. I sure appreciate it.
Yeah, and the same goes to you, Ronnie. Thanks for sharing with us. And this is kind of a point where I want to throw out there that with these night classes, or even the tip of the day for you guys, if you guys are running something that is making your life easier, I kind of look at SolidCAM, you guys are customers as family, and if there's something that that is helping you guys out in your business machining wise, let us know. And we can implement that in, or we can, kind of do it like what we did tonight, and we could make you the presenter and show us what you guys are using, to make things easier as well, like what Ronnie was doing. And Ronnie, pointed out that saying, "Man, I really like this Eureka interface. I'd like to kind of see something on this." And so that's when we kind of send it. Do you want to try it out, Ronnie, and do a little presentation for us and for you guys? And so, like I said, we're not here to push anything on you guys. Just want to show you guys what options are out there for you guys to make your life much easier as a machinist. And we all like our hair, and we like the color of our hair. We don't need it to go gray or fall out, or at least I don't yet at this age. But Ken's got a couple moments. Those of you who met Ken.
What hair? What are you talking about?
I just really want to point out that right here, this is a KevCAM tip right here, and never I come to a class I don't learn something, and I appreciate that.
Yeah, putting that at the 1/10.
Yeah, at the 1/10. Yep. So you don't have that. What do you call it?
The tolerancing issues. Yeah. It's stacked on top of each other. That was the time where Greg Payton was supposed to hop in, but he was off in Germany playing. No, and
somebody's got to do it.
Yeah. No, and like I said, guys, with every night class, so just want to thank you guys for coming in here. Thank you, Ronnie, for doing this presentation tonight. For those of you guys that have maybe possibly noticed, is there's nothing on the schedule as of right now for the night classes. Greg and I are in the process of trying to break down how to show you guys all the great new stuff that is coming in SolidCAM 2018. So that's going to be in the lineup, and we'll get that class updated for you guys as soon as possible. And what we're going to do is, when I did the What's New in 17, it was way too much to throw at you guys at once, and I felt like I was kind of rushing through it. So Greg and I are going to take our time and make sure that you guys are getting that warm, fuzzy feeling when you guys shift over to SolidCAM 18 and kind of know what's coming new, because there is a lot of really cool stuff that they've added in there for 18, and a lot of things to make your guys' life easier too. So we're going to try to go through those each stages of that as well. So
yeah, we'll probably break it down over 3 or 4 classes, and hopefully we'll have that schedule up on the website in the next couple of days.
Yep. So, well, I guess I don't see any other questions here, so we'll kind of wrap things up. And like I said, thank you guys for joining for the night class. Thank you, Ronnie, more than anything, for showing us Eureka and how it works and how it kind of has helped you out as well. So just want to say
thank you very much.
just my 2 cents. Kevin, appreciate you guys doing this KevCAM every week, and Ronnie, great job with the presentation. This is a great, highlight of a product that you're using, and I think this went off really well. So thank you very much for your time and doing that for us, Ronnie.
And,
thank you very much.
And if any of you guys have questions on how to get Eureka or try Eureka out, shoot myself an email or shoot your account manager an email, and we will get you in contact with the right people and get you all the information that you guys need for that. So, all right. Have a great night, guys. And if I don't talk to you in the meantime, we will talk to you guys next Tuesday. Thanks, guys. Have a great evening.
Thank you, guys.